All right, hey folks, we're in your packets right now on page 19, and this video is going to be going along with pages 19, 20, and 21. Before we get started on page 19, I want to remind you guys about an example from elementary school, where if you read the problem here in red that a fitness center charges $2 each time you go, and you have to pay $10 a month no matter what, the question asks how much would someone's bill payment be if they went to the gym 12 times? In this scenario, you're given all of the parts. We're going to have $2 per visit. The 2 is going to be our coefficient. And the $10 that you have to pay every month, no matter what, is the constant. And so we're going to be simplifying the expression by simply plugging in $2 for 12 visits. That would be $24. And then we'd have the constant $10 monthly fee no matter what. So in this situation, if somebody went 12 times, they would spend $34 at the gym. Now on page 19, if the fitness center charges $2 per visit and still charges a $10 monthly fee, I'd like to point out that this time in the problem, we're given that somebody's total bill payment was $34. At this point, we are given the total. So that's the new unit where we're going to write an equation, and when we solve the equation, we'll figure out how many times Nolan worked out at the gym. So it's still the $2 per visit and the $10 monthly fee, except this time we're given the total of 34. And when we drop our line and solve and subtract the $10 monthly fee, we can see that $2 per visit cost him $24. At this point, we can simply divide the 24 by the $2 per visit and see that he must have gone 12 times. So 12 visits. So that's kind of the difference between elementary school math and now with 7th grade, where we're giving you the total and you're dropping the line and solving the equation. All right? Now you've already had an opportunity to go through and try to answer each of these questions. And with the video now, I'm kind of explaining the equation and how you're using the equation to solve. Going from the word problem to the equation, and what I mean by that is going from this part here to this part here, that's the challenging part. So in this scenario, if you've got 8 bus groups and you know that each of those bus groups has 2 parent chaperones, you know that there's 16 chaperones total. So what we can do is we can drop the line here and we can subtract those 16 parent chaperones and get 384 students must be on the bus. If those students are split into 8 bus groups, we can now divide by 8. All right? I'm going to review long division with you guys off to the side when you divide by 8 here. 8 goes into 38 4 times. That's a 32. 6, 4. And that subtracts. So we've got that there must be 48 students in each bus group. All right, now let's take a look at the scenario where Sam's family is going camping. There's a pretty good chance that you might not have known how to fill out this table of values. That's okay. I want to point out that let me actually erase some of this stuff from up here. If the campsite charges $30 to rent the space and then $20 each night you stay, we've got to decide which one of those is going to be the constant and which one of those is going to be the coefficient. Since you get charged $20 for each night that you stay, the $20 per night, the 20 becomes our coefficient. What that means is that the $30 just to rent this space, that's going to be the one-time fee. So if you stay for one night, for example, you're just going to plug in a one night, and 20 times one night is $20, plus the $30 to rent this space, that would cost $50. Now, if you stayed 2 nights, that's $40, and 40 plus 30 is 70. If you stayed 3 nights, 20 times 3 is 60, plus 30 would be $90. If you stay 4 nights, that's 80. 80 plus 30 is going to be $110. And for the last one, if you stay 5 nights, that's $100 plus the 30 to rent this space. Some of you might have noticed over here there's a pattern of plus 20. And that should make sense because it should increase by $20 each night that we stay. Now what we have control over, folks, what we have control over is the number of nights that we stay camping, or that Sam's family has control over the number of nights that he would stay camping. So because he has control of that, that's how we define the independent variable. So the number of nights. And here the number of nights was represented by the variable n, okay? Now what depends on that is going to be the cost. And so the variable c is the dependent variable. Again, this is because Sam's family has control If you have control of something, that's your independent variable. Sam's family has control over the number of nights they stay. And once again, what you have control over, that's independent. And of course, the cost depends on the number of nights you stay. So, that chart up there, you can fill it out kind of easily because elementary school, we know how to plug stuff in and simplify. Now part C is kind of the new 7th grade task. Actually, sorry, excuse me. Part C, this is still 6th grade. You take the 20, you plug in the 5, you add the 30. This is from up here in the chart, and we'd get that it would be a total of $130. In this situation here, we simplify. All right, that takes care of page 19. Now let's move over to page 20. All right, with page 20 at the top, we've got another table to fill out. If you need to pause the video to fill out the table of values, that's fine by me. In this scenario, we've got that a taxi charges a $2 flat fee and $1.50 for each mile driven. So what you can see here, that I have in the table, I have the equation written right here. The 150 per mile, again, that's how you figure out your coefficient. It's multiplied for each mile. And then you add the $2 flat fee. Your flat fee is always going to be your constant. Kind of like in the last problem, the $30 just to rent the camp space, that was the constant. And in the problem before that, we had the 16 parent chaperones, that was a constant. And the $10 monthly fee that you have to pay no matter what, that flat fee, that's going to be your constant every time. Now in this example right here, all I've done is simply plugged in 0 miles, 5 miles, 10 miles, 15 miles, and 20 miles. If you haven't traveled yet, the $2 that's on the meter, that's how much you're going to get charged so far. Now, $1.50 times 5 miles, that's $7.50, and that $7.50 plus the $2 flat fee is going to be $9.50. $1.50 times 10 is $15, and 15 plus 2 is $17. $1.50 times 15 is $22.50 plus 2 is going to be $24.50 here. And for the last one, $1.50 times 20 miles charges 30 minutes, and then add $2, or sorry, it's $30, add 2 is $32. What somebody has control over in this situation is the number of miles that they travel. The driver can't control that. The driver can't control how far the rider needs to go. The rider is the one who decides how far that trip is going to be. And therefore, the cost depends on that, which is represented by C. I want to point out that this is our input. We plug in the number of miles, and each time we got an output. This was the output that we got when we plugged in these numbers. Okay? So that equation here, the cost is found $1.50 per mile plus the $2 no matter what. It's up to you if you want to write the 0 for the 1.50, or you could do the 1.5. All right? If a customer is riding for 18 miles, I want you to ask yourself, is that the total cost, or is the 18 miles one of our inputs? It would be an input. So if we plug in, we are simplifying for this problem, okay? So 18 miles times our $1.50, and then plus the $2 no matter what. So 18 times 1.5 is $27, plus the $2 flat fee, this would be $29. All right, so far all of our problems have kind of been money related, where we're plugging things in and getting an output. Take a look at number 3. In number 3, we're looking at a situation where Emily's grandfather is 73 years old, and that is 5 years more than 4 times old as Martha. What I'm going to do off to the side is write this kind of like our translating notes. I'm going to write that 73 is 5 more than 4 times n. And the other day we learned to box the than, and there's 4 times n. We also circle away the 73 is. We've got 4 times n, that's going to come first. Now show me 5 more than that. So this equation shows that somebody's age is 73, and that's 5 years more than 4 times Martha's age. What we're also asked now is how old is Martha? So we're essentially asked to solve for n. So if we drop our line and subtract the 5, over here we get 68. And now all we have to do is divide 68 by 4. When we divide 68 by 4, that's going to tell us Martha's age. And we get 17 for Martha. Now to check, we can take 17, multiply it by 4, and add 5. And all we got to do is see if that's 73 years old. So 17 times 4 is 68, plus the 5, we get a 73, so we're good to go. All right, let me just erase this for number 4. All right, Rick bought a computer for $1,900, so we're given the total. Now, if you're not familiar about a down payment, that means that you pay it right then and there in the store, and then you can set up a monthly plan to pay off the rest. So some people, when they go to the store, they can pay $1,900 for a computer, but sometimes they can't afford the full amount. So here, kind of like what Rick did, they might go ahead and pay $400 in the store and then set up a payment plan for the rest. So what we've got here is that 5 equal payments plus the $400 that he put down is going to total the cost of the computer. All right? Of course, it's not asking us to solve it. It's asking us if P represents the amount, how much would each payment be? We're going to subtract the 400. 5P here equals 1,500. And when we divide by 5, we'll get that each payment is $300. The equation that we use to solve it is right here. But now let's go identify which one it is. Even though it's in a little bit of a different order, it just puts the total first right here. It says the total and how you pay for it. 5 payment plan plus the $400. All right, and now for the last one here on page 20. Let me just erase this real quick. Ian and his friends go bowling over winter break. At the bowling alley, it charges them $3 to rent bowling shoes and $5.50 per hour of bowling. So if we're being charged $5.50 per hour and $3 to rent the space, that is how we generate the total cost. Earlier in the notes, I put C equals. Here you can see I'm putting equals C, so it doesn't really matter where you put equals the total. Now, what does Ian and his friends have control over right now? They have control over the number of hours that they're going to bowl. So H is the independent variable. What depends on that is going to be the cost. All right? So how much would he be charged if he bowls for 3 hours? $5.50 for 3 hours, plus the $3 to rent the shoe. Now the $5.50 for the 3 hours is $16.50, and now plus the $3 just to rent the shoes, he's going to be charged $19.50. All right? So that takes care of that page, and now let's flip over. All right, now we are on page 21. And a car rental agency charges $50 per day and $3.50 for each mile. Catherine paid $190 for renting the car for 1 day. Which of the following equations could be used to figure out how many miles she drove renting the car that day? So we're told that it's 50 per day. We're also told that she paid $190 just for that 1 day. So we already know she rented for just the 1 day, and now $3.50 per mile. This one can be a little bit confusing. She only rented the car for 1 day, so that's how we know the $50 for that 1 day is the constant. And the $3.50 is how much she's charged per mile. So if we subtract the $50 for renting it just for the day, we get $140. And now we can divide that by the $3.50 to figure out how many miles right here that she drove. This question simply asks us to identify which equation could be used. $3.50 per mile plus the $50 it costs her to rent the car just for that day, and this is how much she spent total that day. So this one's D. All right, for number 7, Laura's grandfather is 80 years old, and that's 5 years more than 3 times as much as Laura. So here's the band. 3 times L goes first. Now show me 5 more. 80 is that age. So if you subtract the 5, we're at 75. Now divide by 3. 25 years old. All right, for number 5, just identifying here another equation. Tom bought an iPad for $8 and went ahead and paid $200 in the store, and now he's going to be paying the rest in 6 equal payments. All right? 6 equal payments plus the $200 that he paid in the store will equal the $800 spent on the iPad. Now, if we want to know how much each equal payment is going to be, we can just solve using that equation. We're going to subtract the $200 that he pays instantly in the store, and he still owes them $600. And when we divide by 6, we can see that he's going to be making $100 payments. He will make 6 of those. Each of them is $100. And now for the last one about Nicole. All we have to do is solve the equation that we're given in the problem. Give me 1 sec to write that down. Sorry, so now I've got the equation written down. It's $4.50 per hour, and then $7 to rent the equipment, and Nicole paid $20.50. So y'all, I want to point out here that we are given the total. When we subtract the $7 from the $20.50, we get $13.50 left over. And if it's $4.50 per hour, and we divide that by the $4.50, we have now solved, and we get 3 hours.